from the West Springfield Public Library. What do compasses, computers, and high-speed trains have in common? They all use magnets to function. Magnets are rocks or metals that create an invisible field around themselves. This field attracts other magnets and certain metals. A magnetic field is concentrated around the ends of the magnets. These ends are called poles, and all magnets have two poles, a north pole and a south pole. And you can feel the magnetic force if you hold the two magnets so that their poles are near each other. If the poles are opposite, north and south, you will feel an attraction between the magnets. If the poles are identical, north to north or south to south, you will feel the magnets repel each other. Some materials are naturally magnetic. Lodestone, a rock that is rich in iron, for example, and certain metals can become magnetic. These include iron, cobalt, and nickel. I just mentioned north poles and south poles. Does that sound familiar? It does, because our Earth is a giant magnet. That is because the Earth's core consists mostly of iron. The Earth's magnetic field stretches out and around the planet. That's called a magnetosphere. The field is strongest near the Earth's north and south poles. You ever wonder why a compass always points north? The reason is that that compass is a magnet that sits on a pivot. This magnet is also often called a needle, and since opposites attract, the south pole of the compass needle is attracted to the Earth's magnetic north pole. So how does a magnet work? The ancient Greeks were among the first people to discover lodestones. To them, magnetism may have seemed like magic. After all, a magnetic field cannot be seen, but its effects can be felt. Over the past century, scientists have learned that magnets' secret lies in its atomic structure. All objects in the universe are made up of atoms, and each atom has a nucleus at its center. Tiny particles called electrons orbit the nucleus, and this process creates magnetic fields around the electrons. The magnetism occurs when the electrons spin all in the same direction. As all magnetic forces from the electrons add up, they make the object into one big magnet. If you run a non-magnetic nail through a magnetic field, you can turn it into a magnet. This process is called magnetization. Here's an experiment that you can try at home with the magnet that we gave you, a nail, and I've got some paper clips here. We're going to try to create our own magnet with this nail. So remember how I said the electrons have to run in the same direction in order to cause it to become magnetized. So that's what we're going to do. We're going to take our magnet and we're going to rub the nail. Always go in the same direction. So we're going to go, in this case, from the head of the nail through, and we're going to do this for about 10 minutes. Okay, it's been about 10 minutes. Let's give this a try. What we're trying to do is change the electrons so they all go in the same direction, which is what causes it to become a magnet. Let's try it out on our paper clip and see if we have done it. There it is. Now, as I said, it's not very strong and it won't last long, but try it with yours and see if you can do it. The flow of electrons is called electricity, and as electrons move through a wire, they create a magnetic field. Scientists believe that magnetism and electricity are part of a single force. It is called the electromagnetic force. Danish physicist Hans Christian Ørsted discovered electromagnetism in 1820. The discovery led to major improvements in the way people live. Scientists began to produce magnets by sending electricity through a coil of wire wrapped around a magnetic material, like iron. This type of magnet is called an electromagnet. Electromagnets can vary in strength. The strength depends upon the size of the electric current and the number of times the wire is coiled. Powerful electromagnets, for example, are used to lift cars in junkyards. Electromagnets are used for a wide range of purposes, including lifting scrap metal. Magnets are found in many devices that people use every day. They are in any machine that has a motor, and that includes fans, washing machines, and cars. Motors use magnets and coils of wire to turn electrical energy into motion. Magnets have also helped bring major advances in the healthcare and transportation fields. Doctors can diagnose medical conditions through an MRI, or magnetic resonance imaging. MRI devices use a magnetic field to create pictures of the patient's organs. In Japan, China, and Germany, high-speed trains use magnets to reach speeds of up to 300 miles per hour. The magnets allow the trains to float above the tracks, and this gets rid of the friction that would otherwise cause the trains to move at slower speeds. Magnetism is a basic force of nature. It surrounds us, and understanding how magnets work has inspired people to constantly develop groundbreaking and life-saving technology. And now on to our project today.
In your bag, you should receive the following items. There should be 3 mazes, a nail, paper clip, craft stick, magnet, 4 stickers, including a happy face sticker, and your paper plate. Begin by adding glue or tape to the craft stick. This will be what you put your magnet on. If you use glue, make sure that you let it dry enough so that this magnet sticks. Next, we're going to take our non-happy face stickers and put them on each of the mazes. Then you can place the maze on the paper plate. I did not stick the maze to the paper plate. That way it can be interchangeable, or you can add your own creative maze. Next, I put the paper clip and added the happy face to the back of the paper clip, and that's it. Try and get your happy face over to your sticker in the middle and have fun with magnets.
And that's it for our March program. I hope you've enjoyed yourself, and I look forward to seeing you in April on Earth Day, April 22nd, where we are going to talk about plants and we're going to make paper with seeds in it. So you can write on it or you can plant it in the ground and grow with it. Until then, stay curious.